welcome to our presentation, Smooth Roads Ahead, Making Wheel Bearing Jobs Work for Your Shop. My name is Brian Sexton, and I am an automotive technical writer for Babcock Media's Shop Owner publication and the speaker for this event. Today's webinar is sponsored by BCA Bearings by NTN. Wheel bearings are safety-critical components which feature precision engineering, robust construction, and a long service life. However, all wheel bearings will eventually need to be replaced. Wheel bearing or hub assembly replacement can present a number of challenges to technicians. This webinar will explore the importance of wheel bearings to the overall vehicle, when, how, and why wheel bearings need to be replaced, and how your shop can more effectively and efficiently manage bearing replacement jobs. Now it's my pleasure to introduce our presenters. I'm happy to introduce Matt Gorski, who's joining us here today. Matt is the Manager of Product Development at NTN Bearing Corporation of America. He started out in the automotive industry as a technician and worked for 12 years before joining the automotive aftermarket as a technical trainer and then moving into product development. Matt joined NTN in 2015 and has led the development of NTN's automotive aftermarket product lines. We also have Dibjo Singh joining us here today. Dibjo is the Senior Applications Engineer at NTN Bearing Corporation of America. Now with that, let's get started with today's presentation. Let's briefly talk about our goals here for today. We're going to discuss the importance of wheel bearings to the overall vehicle and the impacts of extreme usage and environments. We'll identify common customer concerns and how to correctly diagnose the cause. We'll discuss how to select the right replacement part for the job. We'll identify methods for dealing with corrosion buildup between the bearing, the hub, and knuckle. And we'll discuss how to sell and manage difficult bearing replacement jobs, reduce the installation time, and costly comebacks. On to the importance of wheel bearings. Many of us know wheel bearings are safety-critical components to the overall vehicle. They transfer drive force to the wheels, they reduce rolling friction, they provide support for the wheel hub, the wheel, and the brakes, and they help to support the vehicle weight. And that's not just the static load, the curb weight of the vehicle, that's also the dynamic loads, which are seen when cornering. And a great deal of time and effort is put into selecting the right materials, the right types of seals being used, the grease, manufacturing techniques, heat treatment. Matt, here's where I'd like if you could weigh in here on how BCA approaches this step in the process.
Well, what I can tell you is, we take a look at the specifications required for the vehicle in question, so we make sure that we've got the right, ball diameter, contact surface, heat treat areas. We make sure that the wheel studs are correct and piloted to match the OE design. Anything and everything that is required from the OEM, we're going to be targeting for the aftermarket parts and make sure that all the critical dimensions are the same and optimized.
Very good, very good. And I imagine this is an area where someone else could cut corners.
Oh yeah, that happens quite a bit when we take a look at some of the low-cost country and competitive parts that we frequently order to take a look at and compare. You see less than high-grade steel used in some of the wheel studs, non-piloted, so it's a little harder to get the wheel studs, the lug nut started on the vehicle. Length of wheel studs, which is important in some applications, whether you have aluminum wheels or steel. The ABS sensor wire thickness and protective coatings that are on there, weather pack connectors, and the quality of the seal to keep the water and road grime out. But usually it's grease that is surprisingly expensive when you use the right grease. So a lot of shortcuts are taken there, and also in the sealing of the hub assemblies, keeping the road grime out and the good grease in. So.
Right. Part of the key to success is keeping contaminants out and keeping the grease in. All right, and here this leads us right into design criteria. And so what makes a good wheel bearing? A lot of times it boils down to the simplest things here: manufacturing, engineering, and materials. Are all of those three categories up to snuff? And just like Matt said, a bearing is designed based on several expectations. That could be static, radial, axial loads, the wheel and tire diameter, the track, the offset, the weight of the vehicle, the center of gravity, the load capacity. All of these are factors in choosing the correct manufacturing techniques, the right materials, and the overall package. So what can cause a bearing to fail? In many, many cases, it boils down to one of three things: inadequate lubrication, faulty installation, or improper adjustment. That's not to say this is every cause, but this is the most common. Other causes can include environmental contamination. We mentioned earlier about how a seal needs to be able to keep contaminants out of those rolling elements. A curb or a pothole strike can certainly cause a premature failure or noise. And extreme usage. And extreme usage is one of my favorite terms. What qualifies as extreme usage? This is a broad category. We can be talking about off-roading. We can be talking about driving a vehicle on a racetrack, or probably the most common, overloading. So here you can see a half-ton F-150 that is filled to the brim with scaffolding and materials. This truck is almost tucking rear tire. Yes, it can handle this load. It's not over the load capacity, but this is a good example of things to be on the lookout for. If your customer is a contractor and they have a van that is stacked with equipment and shelves and supplies and tools, they can inadvertently push the weight of that vehicle past its intended limit. And this can be a real factor in the lifetime of bearings. The way that they use their vehicle is also a factor. Are they towing a heavy horse trailer, a boat, or a car hauler? All of these are factors which should be considered whenever you start your diagnostic process. And Matt, here, can you tell us a little bit about this example that we see up on the screen?
Well, in this case, what it looks like is on the initial installation of this part, there's a little, you can see in the top, there's two little ears where the ABS wheel speed sensor would clip into, which would determine the distance between the sensor head and the magnetic encoder, which has the red circles around it. You can see it through the little windows in the encoder shielding. And what we noticed is when it was returned in as a warranty part or a labor claim, you can see that the part was dropped, the ears were bent and damaged, and when the wheel speed sensor was clipped into there and engaged, it actually was rubbing up against the magnetic encoder. So as they're backing the vehicle out of the bay, it's actually scraping and destroying the magnetic poles that are embedded into that seal, instantly turning on the ABS light and simulating a failed part, when in fact the part was good. It was the installation that was the error.
Right. And this all happened in a very, very short period of time, right?
Yeah, this would have been as it's put in reverse and backing out. As soon as the wheels start moving, the ABS sensor tip is dragging against that seal and encoder, just tearing it up.
Just great example of an improper installation, improper adjustment. Now, common customer concerns, things that you will hear commonly from customers when describing a wheel bearing. They can use any number of different terms. Most commonly, you'll hear grinding, growling, whining, humming, clicking, or popping. Customers can use come up with some really creative ways of describing these noises, and we'll come back to that here a little bit later. Noises like this are commonly referred to as noise, vibration, and harshness, otherwise known as NVH. NVH is something that can be dampened inside the vehicle by suspension bushings, engine drivetrain mounts, or with counterweights. It's when you start getting NVH that is resonating inside the vehicle cabin, it's when you know that you have something that is going awry. And of course, the next most common customer concern would be an illuminated warning light on the dashboard. This could be electronic stability control, ESP, traction control. This could be ABS, any system that relies on wheel speed sensor readings. This could also include passive tire pressure monitoring systems because they use wheel speed data to calculate the tire pressure. We're going to start off our diagnostic tips here with number one, customer states. This is one of my favorite terms as well, customer interview. The customer interview is a hard thing to get right. And as a technician myself, especially in the dealership world, we were sort of apart from customers. We didn't have a lot of direct customer interaction as technicians in the dealer. In the smaller shops that I worked at, it was the exact opposite. But there is tremendous value to speaking directly to the customer to try and get to the bottom of what it is that they're hearing and when they're hearing it. Or if you are in the dealership or in dealership setting, you can work with your service writer, service advisor to really work hard to document exactly what their concern is. So you need to get to the bottom of it. You need to know exactly what type of noise they're hearing and when it's occurring. You need all of this to know how to duplicate that concern. That's the first step to diagnosis. And then, of course, ask the right questions. Ask them how they use the vehicle, what sort of loads they're carrying, where they're driving, etc. I refer to this as speaking brother-in-law. I think we all, as technicians, we have that friend or that family member who just doesn't speak the same language as we do. They don't speak technician. And we need to be able to try and speak both languages. My best example, I had a customer who had a clicking CV axle, and she told me that the vehicle sounded like it was popping popcorn while she was going around the corner. And it was such a creative way of describing what she was hearing. It took me quite a bit to realize exactly what it was that she was trying to convey. But that one little detail, it set me on the right path. Now, the same thing can happen. Noises from other components can inadvertently be mistaken for bad wheel bearing. The old golf ball in the trunk joke and the soup can underneath the seat. These sort of things, they happen and they can throw you off track. Matt, would you mind jumping in here? Tell us some of the things that you guys have heard on the BCA tech line.
Well, we've heard a lot of the same things that you've described. We've heard things such as, like a beehive buzzing and washboard type of noise. The clicking, typical clipping. It's across the board. Anything and everything that just people can go to and hope that you can then associate the noise that they're talking about with a known noise or known problem. But a lot of times I have no idea what they're talking about.
And sometimes it could just be like debris stuck somewhere in the vehicle, which could be leading to the noise, which they can mistake it as for a wheel bearing, whereas it's not really, it's something else. So that's why we need to really look into what the customer states the issue is.
Yeah, but again, like you said, the verbiage that they use and the references that they point to are sometimes comical, but it's the best that they can do to try and convey the noise that they're hearing.
Right, and there's no one who knows the vehicle better than the customer who's driving it every single day.
Very true.
Moving on to the second tip, talking about the road test. This is maybe one of the most important portions of this whole diagnostic process. Finding the road test route, a driving route around your shop that's efficient, it's fast, and it's that it can be easily replicated can be a real challenge. If you're up in the Rust Belt, like up in Northeast Ohio, we are blessed with rough road surfaces and potholes and all sorts of debris and obstacles in the road. When I worked as a technician in Florida, I had a really hard time finding places to replicate some customer noises because the roads were far superior to what I was used to here in Ohio. If you're struggling to pinpoint the source of a noise, I can't tell you how many times I've had to bring someone else around, or another technician or someone else to sit in the back seat to help me try to pinpoint exactly where that noise is coming from. vehicle cabins, they're echo chambers. They resonate, and it can be really difficult, even for trained ears, to figure out exactly which corner a noise might be coming from. And of course, you have to ask yourself, is this noise constant? Is it related to vehicle speed? Is it engine speed related? Or does it change in tone or volume when you're going around a corner, accelerating, decelerating? All of these things will help you to pinpoint which area, which system this noise is coming from. Now the vehicle's up in the shop, or is in the shop, and it's up in the air. Let's talk about the inspection. This is both the physical and visual inspection of the vehicle. As always, start with the basics. Trust the KISS method. Keep it simple, and you know the rest. Shake down the front end. Look for any signs of loose joints or components. Look for worn or torn bushings, which may be causing a clunk or a knock sort of noise. Spin the wheels and listen and feel for, you can feel if a bearing is starting to growl, oftentimes you can feel that vibration, that resonating coming through the control arm by just wrapping your hand around it. And then of course, take a close look at drive shaft, drivetrain, CV shaft, chassis components, anything that's in the area that could potentially be the source of your abnormal noise. Continuing on with the inspection, once you've started with the basics, now it's time to start thinking outside of the box. If you suspect that a tire is causing the noise or you're not sure, try swapping those tires side to side or front to back, however you're able to make it work on that vehicle. In a few cases we've seen where, check the brake pads, check other systems that you might not think are related, but a sticking brake caliper or a bound up brake pad can cause a very similar dragging metal on metal sort of noise that can be mistaken for a bad wheel bearing. Real world example. We were discussing here before the webinar, a time where one of us had a vehicle that we were doing some, let's call it spirited driving on a gravel road. And a piece of gravel blew up underneath the vehicle and wedged itself between the backside of the rotor and the tin dust shield behind the rotor. And it made a tremendous noise, more than what a little piece of gravel should have been able to make. But it resonated through the whole car, and it sounded just like a bad wheel bearing. This is part of that thinking outside of the box. Sometimes you get that wrench thrown at you, something that you're not expecting. Here's another one. This is from my career. This is out of a BMW F30, approximately a 2015 BMW 3 Series. It had come in for shifter bushings and a few other components, and this linkage had inadvertently been installed back in the vehicle upside down. If you look really close, you can see there's an arrow to the left of the BMW badge stamped in there, and that arrow is supposed to be pointed toward the front of the vehicle. And the distance between that center part of the rod and the two pivot pins, they're not the same. The bottom is closer than the top is. So if this linkage is installed backward, it doesn't sit straight inside that cavity above the transmission and underneath the floor pan. What ended up happening was in a certain gear or gear range, they had a terrible NVH complaint coming through the vehicle, resonated through the whole car, because that linkage in the position that it was in was rubbing up against the stamping, the hole that the shift linkage the shifter went through in the floor pan. And the entire vehicle just became a giant echo chamber for that noise. Other ideas. I was a Mercedes-Benz technician, and we had a somewhat well-known phenomenon around 2011, 2012, where Continental Conti Pro Contact tires would cause a noise that sounded just like a bad wheel bearing. And we're talking from 3, 4, 5 miles an hour on. It sounded like a wheel bearing, but it was because of the radical front end alignment numbers that they ran on those vehicles. They would chop the front tires, and they would make that very, very similar growl. Tip number 4, picking the right tool for the job. I've talked about this in the past. Chassis ears, wireless chassis ears, as they stand today, are worth their weight in gold. You can mount these listening devices onto any component which you think might be causing the noise, and you can compare those noises and signals in real time to one another. When I started out, these were not around. Then they were out and they were wired, which presented its own unique challenges, trying to run wires out of a wheel well or out from underneath the vehicle and into windows so you could plug it into the unit while you were driving. Mechanic stethoscope is a tried and trusted tool for this sort of job. And I would advise, use your best discretion here. If it feels unsafe to have a vehicle up in the air and spinning the tires up to try and replicate the noise, it probably is unsafe. And as vehicles continue to become more and more electronically dependent, many modern vehicles won't let you do it. You can't turn off traction stability control in most modern cars. And as soon as it detects wheel slip, which it will when it's up in the air, it's going to stop the wheels anyway. So again, use your best discretion. These chassis ears are not as expensive as they once were, and they are well worth the upfront cost. Again, right tool for the job. Application-specific tooling is another investment that might hurt the pocketbook up front, but it pays tremendous dividends. It saves technicians from having to remove the entire knuckle, perform an alignment, and all the other duties that would come along with that job. If you see a certain application that is starting to trend, a good example of this would be the early to mid-2000s Ford Explorers. A lot of us know that especially the rear wheel bearings, they're famous for wearing out and growling and having to be replaced, and they can be a bear to get out of the knuckle. If you see trends like that, this sort of tool makes even more financial sense in the long run. Specific tooling, it will lead to better shop efficiency and better profitability for the entire operation. And of course, in a pinch, you can find some tools like this hub tamer here available for rent at local stores. Now let's move up to repair tips. Number one, selecting the right replacement part. This is a frequently asked question. Should I replace just the bearing by itself, or should I go for the entire bearing repair kit? Matt here, I'd love for you to weigh in on what a technician needs to know before making this decision. And by the way, this is a decision which should be made prior to selling the job and certainly prior to starting the job.
Yep, so what I can say is that we do provide, I think it's 35 wheel bearing kits that'll include the wheel flange, snap ring, spindle nut, etc. Where applicable, where we also offer the bearing alone. And this is more of a preference for the technician. Some are very comfortable and can tear apart and repair a cartridge style or Gen 1 bearing without much issue, depending on their location in the country, if they're in the Rust Belt or somewhere where there isn't a lot of corrosion issues. But it's nice to have that option. And in doing so, when you do have a Gen 1 cartridge style bearing replacement, when you're ordering the part, if you're unsure, you might want to try getting the bearing and the kit, and if you can take it apart and it's not rusty and you can reuse the flange and snap ring and nut, that's it's an option for you. But again, it's going to be something that you're going to learn with experience and the shop, type of protocols, what they prefer to do, and sometimes it's even going to be a cost type of thing if you're going to suggest to a customer a good, better, best option. But we do, I personally like the kits. They're a little bit more money, but you have all the replacement pieces that are probably going to be needing repair. So I just sort of bundle it all in there and give the customer the two options.
And of course, when you're selecting the right kit, it's key to look in the catalog, check the service information. There may be build date differences or option codes which can affect which bearing is needed for the application that you're working on. Second repair tip, wheel bearing R&R. This is the good stuff. Let's shift our focus over to removing and replacing the whole assembly. We always recommend, best practice, remove the wheel speed sensor before you try to pull out the wheel bearing. This is applicable to Gen 3 bearings and vehicles where the wheel speed sensor is mounted into the knuckle. I need to clarify that. Removing that wheel speed sensor ahead of time, you reduce the risk or remove the risk of shearing off the nose, the tip of the sensor, or possibly like the one in this photo, striking it with a hammer as you're getting rowdy and trying to get things done. More applicable to manufacturers like Nissan, Infiniti, Subaru. These three manufacturers all have applications where the wheel speed sensor is encased behind the encoder, and if you don't remove the wheel speed sensor first, that's when you'll shear the nose of the sensor off, and then you've got to replace the sensor as well.
Nope, this is just Matt. I just wanted to jump in and say, that the wheel speed sensor, removal procedure is basically only is going to be on a Gen 1 and a Gen 3. So if it's, let me simplify. If the sensor is bolted into the hub assembly, it doesn't need to be removed. If it's bolted into the knuckle assembly, then that's when we would suggest removal of it before trying to take the hub assembly out of the knuckle. Just wanted to throw a little clarity in there.
Right, good. That's a good clarification. If you're ever in doubt, BCA's website has a terrific library of resources, videos, which outline the removal and installation processes for a number of different applications. Now, when it comes time to dealing with corrosion buildup between the bearing and the hub and the knuckle, let's talk safe cleaning methods first. Myself, I would always trust a wire wheel by hand and trusty brake clean. The stuff, if there's two substances that shots go through the fastest, it's probably brake cleaner and coffee. Am I right?
Mm-hmm.
You want a clean bearing bore and clean surface in the knuckle before you start to put the new bearing back into place. When it comes to never seize, everybody has a different opinion on this. Myself, I use as little as possible, and I'm only going to use it in the contact patches between the hub's mounting flange and the knuckle. I'm not going to coat the inside of the bearing bore. It's not worth the risk of overusing it and having it drip or boil and drop down and contaminate the braking surfaces, which are, of course, right next door. And I would stress the importance of proper torquing procedures and tools. This is not an ugga-dugga sort of situation. This is a torque wrench. Follow the service information, follow the torque specs. These are all simple things that you can do to help maximize service life of that bearing and keep your customer happier for as long as possible. Another point to make on Gen 2 and Gen 3 bolt-on units. If you're struggling to try and get a wheel bearing to start moving inside the knuckle, don't use an air chisel and try to wedge it between the mounting flange and the knuckle. All you will do is damage both components and maybe bind the wheel bearing up even more severely than it was before. What you want to do is use your chisel or your pointer bit to rotate the hub unit inside the knuckle. This is going to help you to break up that galvanic corrosion and get that wheel bearing to start moving for you. And we'll wrap up our repair tips with this. Oh, nope, I take that back. I see a question coming through here from Jim. He's asking, can an induction heater help with removing one of these hub assemblies? Matt, what's your take?
My take is I've never had good luck with it. Induction heaters are good for bolts and nuts, not for large masses of steel like a hub assembly. It may help if the bolt that's holding the hub assembly to the knuckle is hard to break loose or come clean. You might be able to get enough heat at the threaded section, but getting that whole hub assembly heated up is next to impossible to do without the blue red. So throwing a torch on there is really the only other option, but just too big of a mass of steel.
Right. And I've got John here also asking, how much time do you think we should spend trying to remove a hub before we start thinking about other options? That's a good one.
Well, again, that's going to depend on your experience and patience, I guess. Mine, as I got older, got less and less. But you gotta carefully, know when to give up the ghost and not be spending 6 hours on a 2-hour job. So, it's going to be if you have to take the upper and lower ball joints out or the strut assembly loose to take the knuckle off the vehicle and try and get at it from the backside, that might be faster than, still trying to beat on it with a sledgehammer or pry the thing loose. So unfortunately, some of those decisions, are only going to come with experience and trial and error. So hopefully there's some other people in the shop that you might be able to lean to and say, hey, what do you think here? Should I keep beating on this thing, or do you know a tip or trick? And, again, everyone's going to have their own tips and tricks. Mine is that seems to work the best is to, the 3 or 4 mounting bolts that come in from the back side of the knuckle. If you crack those things loose 2 or 3 turns and then get a socket on there with an extension that you don't mind beating on it with an air hammer, even adapter, just try and drive those bolts forward or outwards from the knuckle. A lot of times you can get some leverage back there and push them through instead of trying to pull them through. Again, it all depends on the vehicle with aluminum, steel knuckles, how much time you're going to waste, and if you can even get a new knuckle if damaging that knuckle is a possibility. So it's a tough call.
And best advice would be, especially as you're learning, be flexible. Don't be afraid to change, to look at other options as you're going. Mm-hmm. The worst thing that you can do sometimes is just put your head down and think, I got to get this done. I got to get this done. And sometimes you can dig yourself into a hole it's hard to get out of by just not being cognizant of how much time you're spending on a particular job like that. You got to let the pride go. You can't. Some of us, we like to say, "Oh, I'm gonna beat this thing. It's challenging me. I'm gonna win." Sometimes we have to know when to reassess. And as the old saying goes, "No battle plan ever survived enemy contact."
Yeah, but again, we're lucky in this day and age to have some helpful tips and trick videos and webinars such as this. And when that's not available, just lean on some of your fellow technicians that might have a known shortcut that's safe and productive.
Absolutely. Okay, let's move on to unboxing the new wheel bearing. This is a super quick step, but sometimes it gets missed if we're in a hurry. Compare the 2 bearings. Do they match? Are the bolt patterns the same? Is the connector the same? Is the harness length the same? All of these things, does it really look like it's the same exact part as what you removed from the vehicle? And if there is a difference, why is there a difference? A lot of times you can catch, if there is some sort of error that's happened, it's better to catch it at this point than after you've installed it or tried to install it into the vehicle. And Matt, I know you guys get asked this quite a bit. If a bearing is difficult to spin by hand, brand new, fresh out of the box, is this a normal condition, and what is it that causes that?
Well, it is, and sometimes we get people that'll call us up and say, hey, I got, every bearing that I get is bad. I take it out of the box and I spin it in my hand like, I'm cracking a safe, and I can feel the roughness and harshness and the jaggedy feel. And what they don't understand is, during production, storage, and shipping, that grease that's in that unit can kind of get solidified and set up, if you will, and the crystalline structures are not fluid, so they are not going to feel smooth out of the box. Only after putting it on the car and driving it a while and getting that grease heated up and sloshed around and resituated are you going to get a smooth feel. So, the old, spin test in the hand on the parts counter really doesn't determine good or bad.
Very good. During this step, you're comparing your 2 bearings, and you realize that the new bearing has a hole inside it for a CV axle, but the one you removed did not. You may question yourself, do I have the wrong part? Did they send me the wrong part? There's a GM Bolton from back in 2009. So this one's not news. This is not new, but it is relevant. This Bolton covered revised wheel bearings for a number of GM heavy-duty trucks. What they did was they reduced 7 Gen 2 SKUs down to just 3 Gen 3 SKUs. This is a part of a trend which is becoming more and more popular as automotive manufacturers try to save money and consolidate their assets, or their expenses, I'm sorry. It's called catalog consolidation. What they're trying to do is reduce the number of parts that they have to carry in their catalog, hold on the shelf, and ship out to dealerships. And by reducing that, they're reducing their footprint, they're reducing their inventory on hand, and they're saving the corporations a ton of money. But it adds to, it can end up being confusing for technicians and folks on the front line and on the parts counter when you get something like this. Now, this is normal and it is okay, thanks to Gen 3 housings and their orbital forming, which sets preload straight from the factory. So we have another example here. This was a picture that Matt was kind enough to provide from a I forget what this was on a half-ton pickup, I believe.
Yeah,
or an SUV.
It was I think it was a Chevy rear-wheel drive half-ton truck. Correct.
Yeah, and as you can see, this hub had been installed for quite a while, and the inside of the axle splines are quite rusted out. And this is an okay scenario because of the way that these bearings are designed and manufactured. Another great example of this here, Lou, I saw your question here about any special scenarios for hybrids and electric vehicles. The best example I have is Tesla Model S, and I think the SUVs as well, the X and the Y. They're single and dual motor applications. They share the same wheel bearings, front and rear. So even if the Tesla is only two-wheel drive, the non-driven axle will still have CV splines inside the bearing assembly. So you can run into this in a number of applications and manufacturers.
Yeah, I'll jump in here. They're not only doing that for the driven and non-driven hubs, but they're also doing it with if the vehicle has ABS or non-ABS. So there used to be two different hubs. So now they're going to sell the hub with the ABS magnetic encoder seal that fits all applications, reducing, inventory dollars and all sorts of other things. So they're doing all sorts of things they can to reduce SKU count dollars and streamline cataloging. So it's a lot easier. Not everyone's going to know if it's got ABS or not, and then you're guessing and returning a part. And it makes sense, and I think the more people are dealing with it and they see it, they're going to be more comfortable with it as well.
Right. And this was starting to become a trend well before the phrase supply chain issues was really a phrase. This was, pre-pandemic, this was a push. I remember Chevy and Mercedes both making moves like this when I was turning wrenches professionally, just a decade ago. So you will run into this, all makes, all models, all areas of the world, wherever the manufacturer is from. They're all trying to do things like this to try and help their bottom line. Repairs done, let's move on to post-repair road test. This is, again, another step that should be pretty quick and efficient, but it's something that can be rushed or skipped altogether. Let's say it's almost freedom 30 and you're ready to get out of the shop and get home. There might be that temptation to just ship the vehicle, send the repair order up, and be done. The way I look at it is this is a really, really important step. Would you rather an issue, an unrelated issue, present itself now to you as a technician, or would you rather it present itself to your customer after they've cut you a check and they're driving home thinking that their vehicle is done and repaired? I know I'd rather catch it myself. Even if it's an error that I made, I would certainly rather catch that at that point. Or if it's an unrelated noise which couldn't be heard over the noise complaint that originated the repair, I would still rather know now so that I can talk with the customer, or my service writer can talk with the customer ahead of time to manage expectations. And we should always, always, always confirm our repair. Now, in the event of a customer comeback, I think, speaking for myself, this is a moment I always dreaded. It triggers an immediate moment or several moments of self-doubt, and you're asking yourself, did you get it right? Did you get it wrong? Did you do something? Did you miss something? Best advice I ever got was take it, swallow it, come back at it again with fresh eyes from a new angle. Again, thinking outside of the box. Check for some of the things that we've talked about here. Check for that air gap between the wheel speed sensor and the encoder ring. Check for maybe a damaged or fraying sensor harness that could have caused an ABS or traction control light after the repair job was done. And of course, one of the best pieces of advice I ever got in the shops, and I still hear it ringing in my ear every day. My first mentor, he told me, go back to whatever was touched last, even if it wasn't you who did the last job. It's not to say you point the finger at whoever was in there last, that sort of thing. It's just if you made a repair and after that repair was made, something new has come up, even if you think it's unrelated, go through it with a fine-tooth comb and go back to whatever was touched last and really confirm for yourself that that previous repair had nothing to do with what has now come to the surface. We all make mistakes. I certainly made my fair share of them. The most important thing is to try and learn from them and not make them repeatedly.
And, you know, I'd just jump in here. Speaking from a warranty and labor claim standpoint, some of the things that we see quite often is there are multiple part numbers and applications where you have shared years, like an '07 Chevy Silverado 1500. They had the Classic, which was torsion bar suspension, then they had the new body style with the coil spring suspension. There's two different part numbers for that year. So a lot of times some people will look it up, grab the first number that pops up on the screen, assuming that's the only one, not asking the question, is it the new body style or the Classic? They will bolt up, they will plug in, and they are identical, but one has got a passive ABS sensor and one's got an active. So you're going to have an ABS light come on all day long, even when you're replacing the same part that you think has failed because it was manufactured faulty. So sometimes it's just as simple as making sure you've got the applications correct with all the ifs, ands, or buts, and you're getting the right part number.
Right. Measure twice, cut once, right?
Something like that, yeah.
Something like that. All right. There was another scenario we were talking about before the webinar here. Speaking of coming at it with fresh eyes, there was a Gen 1 bearing housing that had been replaced, and then vehicle came back in with traction control, stability control, ABS lights. Matt, correct me if I'm wrong. That was the bearing had been installed backwards, so the magnetic encoder wasn't aligned with the.
Yeah, I would say that 98% of all the Gen 1 cartridge style bearing warranties and labor claims that we see are one of two things. One, it's been installed with the incorrect spacers, tools, and press adapters, and you're going to see that some of them kick in and will crush that ABS magnetic encoder that's got the magnetic poles in it. The other part is that encoder with the magnetic poles needs to be installed inwards towards the engine, towards the ABS sensor that's mounted in the knuckle assembly. You got a 50-50 shot. A lot of people don't know that it is directional. In a lot of the cases, what we're doing is we're putting, where applicable, an encoder on both sides so that, you know, we eliminate that possibility of incorrect installation. But, you know, someone new or not having a good day or paying attention might install it backwards, and it's going to instantly turn on an ABS light. And those are not the style you can just unbolt or pop out and turn around and put back in. So it's an expensive oops because there's a lot of labor to get to that cartridge assembly.
And of course, that's an easy thing to check since it's, you know, it's a magnetic encoder. You can tell which side has that encoder ring on it before you go to install.
Just throw a little paper clip on it, and it'll stick to the side that needs to be mounted towards the sensor.
And I see here Pierre has asked, back on slide 7, we were talking about the ABS sensor that was destroyed. Matt, can you just give us a little bit more detail on this scenario and what happened that caused that wear?
Sure. At about the 11:30 or 12 o'clock, you see that little the two prongs that are part of the encoder shield is what we call it, and that is where the ABS sensor is going to clip into, and that's a kind of a precision mount so that it has the right air gap between the encoder and the sensor. So what happened was this got dropped, hit, damaged, so one of the ears was pushed in, which eliminated the air gap to just direct contact. So when they clip that ABS sensor into that two-prong retainer, it didn't have any air gap. It just pushed it and smashed it right up against the encoder, and the installer didn't notice it. And then, you know, I guess if they would have spun the wheel to make sure it wasn't, you know, having any drag issues, they might have caught it at that point. But I think they just, you know, bolted it in, popped that in, put the wheels back on, backed it out, and ABS light came on immediately. So these are rare to have this type of mount for an ABS sensor. Usually they are bolted into the knuckle with a little 10 millimeter bolt. But this was you know, something that we just grabbed as a photo, kind of displaying the importance of inspecting the part before it goes in the vehicle to make sure there's no signs of damage in shipment, or, you know, some of these part delivery guys just sort of drop the part on the shop floor, kick it down to the bay, and, you know, you don't know what kind of damage may be done rolling around the back of some of those delivery trucks. So, you know, just take the extra care to inspect it, make sure there's no damage, and you can eliminate some comebacks and headaches afterwards.
And of course, yeah, this is the sort of thing that can come up during that just brief comparison between the new and the old part. You might, looking at this, you might not recognize that those ears are bent, but if you're comparing it to the old bearing, it might be a lot more obvious to your eyes.
Mm-hmm.
Alrighty. All right, let's go right into our Q&A session. Let me answer some questions. First one, coming from Amanda. She's asking, can you remove a Gen 1 cartridge style bearing from the knuckle while it is still on the vehicle?
Well, I'll jump in. Yeah, you can if you've got the right tools and equipment to do it. Like we pointed out in one of the slides, you know, the hub tamer, the hub grappler, whatever brand OTC, you know, you have in the shop. You know, you're going to make a small investment, but like you said, it's going to pay dividends. And once you get more familiar with it, you're going to be able to eliminate pulling the knuckle off and bringing it to the press and setting up the spacers and trying to get that thing lined up to press out the wheel hub flange. So it can be done. It's just going to, you know, take some practice and investment in tools.
Here we have another question from Jeremy. He is asking, why are there multiple torque values listed for some hub assemblies? I imagine this has to do with some of those applications where there are multiple, there are option codes which could affect which bearing that application is going to need.
Possibly, but what I can tell you is, in my experience, the torque spec is specific to the application and not the part. The application can change, and what would change in it would be the length or depth or the thread size on the actual nut coming out of the axle shaft assembly. So, you know, that's another reason why a lot of companies don't put new axle nuts in the box with the hub assembly, because there might be 4 or 5 different axle nut sizes that fit the 7 or 8 different vehicles that part fits. So again, the torque spec is specific to the vehicle, the GVW that it's going to be carrying, and the axle assembly with the splines and the spline depths and spline engagement, that type of thing.
Right, right. And just as a clarification, in case by that they meant there are, in my head I'm imagining they could be referring to torque to yield hardware, multiple torque specs starting out with an initial torque and then a rotation. That would be in an application, maybe an import with a stretch CV bolt, where you have to set initial torque and then a degree of rotation to stretch that bolt and apply that maximum clamping force as the OEM has outlined in their service info. So that's also something to be aware of. You don't see it as much on the domestic side, or at least I didn't.
I was going to say that's the Mercedes history in you coming out. So yeah, in some applications, yes, there are bolt nuts that would do the same type of purpose. So there are a few applications where there's an axle bolt and not a nut, but that's correct.
All right, and here I got a question from Timothy. He's asking, should bolts be replaced on bolt-on assemblies? I'm imagining he's talking about the bolts that secure the hub unit to the knuckle. My advice here would be check the service information and check the hardware that you removed, if you see evidence of thread locker or some other substance that's applied to the threads, you may need to replace them.
I would agree. And again, the bolts that attach the hub to the knuckle are going to change from vehicle to vehicle, even though the part number is the same. So the length would change depending on the knuckle, if it's got a steel or aluminum knuckle. So yes, you'd have to be application specific if you were looking to replace the bolts. But most OEM service guidelines are to replace the mounting bolt and the axle nut, but that's up to the installer in the shop with their experience level.
All right, moving on here, I got a question from Bruce. He is asking, can a damaged wheel speed sensor harness on the vehicle side be repaired if it's damaged? Matt, I'd love to hear your take on this one.
Well, I think that Andrew Markell did a video on this in the past, and again, that's an area that I don't feel comfortable giving any advice, because it is something that is kind of shied away from in the repair business, because it would be a soldering expertise type of thing, because some of these have 5-volt references that are going back and forth to the BCM and ECM, and you're going to get a voltage drop, any kind of resistance. If your solder isn't 100%, it could be enough to cause a false modulation or trigger a ABS traction control issue. So again, it's something that I know has been done, can be done if you're skilled with solder and electrical work, but it isn't something that I would recommend for anyone that isn't very, very comfortable with electronics.
Very good. And here we've got one final question. This one is coming from Patrick. He's asking if the front hubs on a Nissan Xterra 4x4 require preload from the axle nut, or is the torque spec for the axle nut just to keep the axle tight inside the hub? This is a tough question to answer definitively. I'm not familiar with the application. I know that there are some applications where that CV axle bolt or nut torque is in fact there to keep the axle tight inside the splines and not to apply preload. The question would be, is this a Gen 3 hub assembly where preload is set from the factory? And is there anything else that we might be missing? I would rely on service information here to tell us what we would need to know, or checking the parts catalog and seeing if those part numbers have been consolidated, like what we talked about with our example with the Chevy pickups.
Yeah, we do get this question quite a bit, and I think we may have even gotten an email on this exact application. But what it is sometimes some installers or do-it-yourselfers are thinking, well, it looks the same as the two-wheel drive, but it doesn't, I have a two-wheel drive, they're out of stock, and I use the four-wheel drive instead, because you spoke of some applications where the driven can be used in an all-wheel drive application. And again, two things I would caution against. One, is it a rolled or orbitally closed unit? You have to have a kind of a trained eye to see what that is and how it is. And what that is it's capturing the wheel flange to the hub assembly so that it doesn't slide out. Because in the older cases, the axle shaft with the nut actually held all those pieces together on a four-wheel drive application. And if you didn't have that, the wheel would actually slide out and fall off. So whether or not it's a trapped inner ring or wheel flange design, but also like you said, it could be, if it is a rolled closure design, you could have problems with the, if you install that on the two-wheel drive, I sometimes shudder and shy away from giving any kind of advice that isn't OE approved and OE tested. So it's just, don't be guessing and thinking it's the same and you're going to bolt it up and you'll be fine, because you can get yourself in a heap of trouble and danger by guessing that way. I just don't want to.
It's not something to gamble with.
No, exactly.
Well, that's all the time that we have for a Q&A session. I want to thank Matt and Divjo and your team for coming in and speaking with us today. Your advice has been terrific, and your input. And this concludes our webinar this afternoon. I want to thank everybody for their time, and everybody have a great day.